Okay, so another simply supported beam question. This time we're looking at the 2018 paper in January. Question 10 came up, and this time this question was worth 7 marks. So what are we asked to do? Well, we're given a diagram of a beam and we're told it's in static equilibrium, and what we're told to do is to find the reaction force at B. Okay, so first thing to do is to redraw this. We have a UDL, we want to resolve that. So remember, a UDL acts across the beam shown. So it's 20 newtons per meter, it's acting at 5 meter. We want to get that as a point load. So how do we do that? Well, we have 20. That 20 acts across the full length of the beam. 20 by 5, 100. So because I had a newton per meter times a meter, they're cancelling, it's equal to Newton. So I know instead of having that 20 newtons per meter, I can have a 100 Newton force acting somewhere. Where does it act? Well, resolved point load acts at the center. So it's not the center of the entire beam, it's the center of the length or distance it's acting over. In this case, because it's acting over the entire length of the beam, it is half the beam, but just be careful, it's not always like that. So acts at 5 over 2 acts at 2.5 meters. Okay. So I'm very quickly going to redraw my beam using a free body diagram, and it should hopefully become that bit easier to analyze. So I still have reaction forces A and B. That 50 newtons, that's still there, it hasn't gone anywhere. Now I need to put in my 100 newtons and fill in my distance information. Okay, so that 50 newtons hasn't moved, that's still 2 meters away. This 100 newtons, it's at 2.5 meters away. So it's at halfway, and the total distance 2.5 meters. So the total distance of my beam is 5. That's a quick check. Okay, so nothing has changed. That's still 5. And we're ready to go and solve for B. So because we know it's in static equilibrium, if I take the moments about this point A, static equilibrium means the moments should equal 0, so it's not moving. Okay, so on your answer you would need to put in all this information. I'm just doing it to try and help as a bit of a refresh. Static equilibrium, sum of the forces equals 0, and the sum of your moments need to equal 0. So a moment is equal to force times perpendicular distance. So let's have a very quick look at this and see what's happening. If I'm fixed at A, okay, this 50 newtons would push me clockwise. If I'm fixed at A, only looking at this 100, and that should be 100 newtons. I forgot to add in my unit. Okay, so if I'm only looking at that 100 newtons, if I'm fixed here, that force is pushing me down, it's going to push me clockwise. The force at B, however, is going to push me counterclockwise. So we're in another room, so let's move up here a tiny little bit. So the sum of my forces equals 0. So at A won't have one. What that means is that, oh sorry, just to very quickly refresh where this is coming from. We've covered in class that when we're looking at moments, we're always going to take clockwise moments to be positive and counterclockwise moments to be negative. Okay, so I have 50 newtons, that's my force. My perpendicular distance A, I need the horizontal distance, is 2. And that's a positive moment, so that's positive, plus my 100 is my force. My perpendicular distance, and be careful here, this is the total distance away from A. So like 2.5, that's positive, so that's okay. Minus, can I move this slightly? Maybe not, okay. Minus B, How far away is B from A? So it's a distance of 5 equals 0. Okay, so all these moments should equal to 0 if it's going to be in equilibrium. So I have 50 times 2 gives me 100 Newton meters. 100 by 2.5 gives me 250 Newton meters. Minus 5 Bm equals 0. So 350 Newton meters minus 5 Bm is equal to 0. I'm going to get rid of that M. Probably only going to confuse us. Okay, so if I rearrange this, I want to get B by itself. First thing I'm going to do is bring the 350 over, and what happens is it becomes negative. So now I have minus 5 B is equal to negative 350. Okay. B is equal to minus 350. So the opposite of multiplying by minus 5B is dividing by minus 5. So the minuses cancel and I get 70. So I know B is 70, but 70 what? Well, I was looking for a force. I'm using the unit in newtons. B is equal to 70 newtons. Okay, and that's the solution to that one. So I know it's a bit complicated. Obviously, if you're in an exam, you don't need to do all of this writing on the right hand side. You can just know it. But hopefully that would be another nice easy question, and it should ideally get us the full 7 marks. Okay, if you have any questions, please let me know, and I'll try and come back and explain anything I've missed.